substitution method. Let us explain substitution by going over some examples. Suppose you're interested in evaluating the integral of x times x squared minus 1 to power 99 dx. Okay. So the quantity inside the parentheses has a large exponent. What are we going to do? We're going to introduce a new variable. Let us use u to be x squared minus 1. Well, inside your integral, you have dx, you don't have du. So we need to find the differential of the quantity here. If I take the differential, I have du, which is 2x dx. Well, I have x dx inside my integral. X dx is just right here. I see it right here. But I don't have a 2. What you can do? You can multiply and divide by 2. Multiply and divide by 2. Now you have 2x dx. Or you can say that, hey, since du is equal to 2x dx can be written as du divided by 2x. But remember that if you use the or, you cannot create a new variable inside your integral. This case is only working if you have x dx inside your integral. Perfect. So let me just make this a little bit smaller. This integral can be written as the integral of wherever you see x squared minus 1, you're going to use u. So you have u to power 99. And since you have x dx, for dx, you're going to use du divided by 2x. And as you can see, x and x, they get cancelled out. So your integral becomes the integral of u to power 99 du divided by 2. So again, wherever you see x squared minus 1, you're going to use substitution by a new variable u. So this guy can be written as a half the integral of u to power 99 du, which is familiar. We have seen this integral before. Recall that if you have the integral of x to power n, or in general u to power n, du, it is u to power n plus 1 divided by n plus 1. So we're going to use the familiar formula that we applied multiple times in calculus. So this can be written as a half, and then the new exponent is 99 plus 1 divided by 99 plus 1 plus constant of integration. In turns, this integral is 1 divided by 2 times u to power 100 divided by 100 plus c. But remember that your original integral is in x, so you have to rewrite this in terms of x. Don't leave it in u. So you have x squared minus 1 to power 100 divided by 200 plus constant of integration. So this is the method of substitution. We're introducing a new variable like u and try to simplify the integral into something that we saw before. It's familiar for us. So this integral, we saw this integral before. We know how to apply the formula. So substitution method helps you to simplify your integral into something more familiar. But remember that again, at the end, make sure you substitute everything back so you have your integrals in terms of x, not u. So far we saw that if we have a quantity and it has some exponents, we take that quantity to be u. Now, suppose that quantity is inside or on the denominator. Let's take a look at this case. Here we have the integral of dx divided by 2x plus 1 to the second power. Your quantity now is on the denominator. It has some exponent and it is on the denominator. It's a common mistake for students that they start expanding the denominator. Don't do that. We're going to use the method of substitution. Let u be 2x plus 1, so du becomes 2 dx. Or dx is du divided by 2. So this integral can be written as, wherever you see dx, write down du divided by 2. And on the denominator, you have u squared, because u is 2x plus 1. U squared. Okay. So let us simplify this integral. This is the integral of du divided by 2u squared. You can write a half in front of your integral. This becomes a half. The integral of du divided by u squared, which is familiar to us. We know how to deal with this integral. To calculate this integral, we remind ourselves of the integral of u to power n du, which is u to power n plus 1 over n plus 1 plus constant of integration. This is something that we saw before. Nothing new. But how I see that it is on the denominator. Okay, we can write it on the numerator. This is a half the integral of u to power negative 2 du, and your n is equal to negative 2. So the integral of u to power negative 2 du is u to power negative 2 plus 1 divided by negative 2 plus 1 plus constant of integration, or this integral can be written as u to power negative 1 divided by negative 1 plus c, or in more shorter version, the integral of negative 2 du is negative 1 over u plus c. Let us go back to our integral. This becomes a half negative 1 over u plus c. But what is u? U is 2x plus 1. You have to substitute this guy back here. You have negative times negative. You can write it as negative 1 divided by 2 times 2x plus 1 plus constant of integration. So this is your final answer.